You may remember factoring quadratic equations or quadratic functions or polynomials in general. We covered yesterday one way to solve quadratic equations is to graph the quadratic function and find the x-intercepts. But we also saw that graphing doesn't always provide the easiest way to get exact answers. So there's other ways to solve quadratic equations, and factoring is one of those ways. We are not covering all methods for factoring today. We're reviewing 3 different methods of factoring that you would have covered in Algebra 1, and we'll continue with factoring when we come back from Thanksgiving break. But one thing I want you to understand, so again, I know I'm trying to stress more, don't just know how to do something, but know why you are doing it. You have to have that understanding of what you're doing. So why do we even factor? So if you want to write somewhere on your sheet what factor actually means, factor means to write, or you could even say to change a sum or difference. So I'm going to abbreviate difference here. So to write or to change a sum or difference into a product. That is the whole purpose of factoring. That's what it means. So if you look at, you could look at any on this front page, but even if you just look at 1, 2, and 3, these as they're already written, number 1, for example, this is a sum of 2 terms. 2 terms are being added together. Number 2 is a sum and difference of 3 terms. Number 3, same thing, is a sum and difference of 3 terms. So when you're factoring, you're changing that sum or difference into a product of terms. So if we look at these first 3, the first method of factoring we're going to talk about, and this is actually the method you should always use first. So whenever you're factoring, you should always check for this first. These 3 are going to review factoring out the GCF. Greatest common factor. So however many terms you have, anytime you're asked to factor, this should always be what you look for first. If there is a GCF, it should be factored out first. So if we look at number 1, looking at the 2 terms, 27y squared and 18y, we're looking to see what's the greatest common factor. What do those 2 terms have in common? So first, you can look at the coefficients, the 27 and the 18. What would be the greatest common factor for 27 and 18? 9. The greatest number that goes into 27 and 18 would be 9. And then you look at your variables. So if we have y squared and then we have y, and this second y would be to the first power, they both share a y just to the first power though. So one of them has y squared, one of them has y, so it's the variable to the smallest power that you see would be part of the GCF. So when I write this in factored form, I'm going to write the GCF of 9y in front of a set of parentheses, and what goes in the parentheses is what you're left with when you divide each term by the GCF. So factoring something out means you're dividing it out of those terms. So if I divide 27y squared by 9y, 27 divided by 9 is 3, and then y squared divided by y, I have y squared. I'm taking a y out, but I still have a y there. So 27y squared divided by 9y would be 3y. And then plus 18y divided by 9y. 18 divided by 9 is 2. Y divided by y, that would cancel out, so it's just 2. So I have 9y times the quantity 3y plus 2. This is the factored form. Okay, and what I want you to notice is we started with a sum of 2 terms, and now that it's factored, so there's not a multiplication symbol written, but in between the 9y and this quantity in parentheses, we are multiplying there. So we now have a product of two quantities. We have 9y times 3y plus 2. So we took our sum and we factored it, so we wrote it as a product. That is the whole purpose of factoring. And why we do this, we can use this to solve quadratic equations. We're going to get to that with the examples on the back, but I just want to review factoring first before we get to solving. Questions on number 1. When you factor, you can check your answers. You can check that you factored correctly. How would I check this? I could distribute the 9y, and if I get the original problem after I distribute, I know that I factored it correctly. So it's factoring is kind of like dividing. So then you can multiply what your answer is to see did you get the original problem back. So if we look at number 2, we have 3 terms this time. What do they have in common? What would the GCF be? They have a 2 in common. What about variables? They each have an a and a b, both to the first power. Okay, so I'm going to factor out a 2ab. If I divide the first term by 2ab, what am I left with? Negative 4 divided by 2 would be negative 2. A squared divided by a would still be a. B divided by b, the b's would cancel. So I just have negative 2a. I'm going to bring down that minus sign for the next term. 8ab squared divided by 2ab. 8 divided by 2 is 4. A divided by a is gone. B squared divided by b is b. So minus 4b. Plus, and then 2ab divided by itself. It cancels out to be what number? A 1, not a 0. So you do have to have the 1 there. If something cancels out, it's a 1. And this would be the factored form. And again, we started with a sum and difference of 3 terms, and now we have 2ab multiplied by a second quantity, so we have a product. Okay, so in your groups, I want you to factor number 3. Factor number 3, and then we'll check it. All right, so double check what you have. I just wanted to make sure everybody had a chance to look at example 3. So GCF would be UT or 1 UT. You could have the 1 written in front, that would be okay. And then check what you have when you factor it out. And I did see some, technically if you're taking out a greatest common factor, a positive is greater than a negative, but you can always take out a negative. So if you do take out a negative, sometimes we want to take out a negative. If you do take out a negative, then just know that your signs here would all be the opposite, and that's okay. I wouldn't mark that wrong if you also factored out the negative. So any questions right now factoring out a GCF? Okay, so then in examples 4 and 5, so again, now anytime we factor, we're still looking for a GCF first, but now examples 4 and 5 and then examples 6, 7, and 8 have specific methods we can use to factor based on the number of terms. So how many terms are in examples 4 and 5? There's 4 terms in each. When you have 4 or more terms, after you look for a GCF, you factor by grouping. If you want to make a note to yourself, this is with 4 or more terms. Typically, you're just going to see the 4 terms later on, actually in second semester, I believe it is, or maybe even chapter 5. We are going to be factoring, probably factoring will come up the rest of this year after this chapter, but we do see factor by grouping later on, not in this chapter, with 6 terms as well. So to factor by grouping, let's look at example 4. First of all, if you look at all 4 terms, do all 4 terms have anything in common other than 1? I heard some no's. So there's pairs of terms that have something in common, but not all 4. So when you factor by grouping, you're taking your 4 terms and you're making groups of 2. So typically you can just group the first 2 terms together and then the last 2 terms together. If you wanted to rearrange your 4 terms and then group it differently that way, you can still do that. But you don't have to. Typically you can group the first 2 and the last 2 the way it's written. And so we're just going to look at the first 2 terms. So we're going to ignore the minus 4n minus 20 for right now. So with 3np and 15p, you're going to find the GCF. So what do they have in common? 3p. And so then you're going to factor out a 3p from just those 2 terms. So if I take out a 3p from those 2 terms, what I'm left with, so 3np divided by 3p would just be n, or if you put 1n, that's okay. And then plus 15p divided by 3p would be 5. So I have 3p times the quantity n plus 5. Then I look at the last 2 terms and I do the same thing. So I have negative 4n minus 20. What do they have in common? 4. I heard 4 and I heard negative 4. So here's when you should take the negative out with it. If in either of your 2 pairs, if the first one in the pair is negative, you should take the negative out. So that would have been the same in my first 2 terms. If the 3np was negative, I would have wanted to take out the negative, a negative 3p versus a positive. So I'm going to take out a negative 4 because the 4n is negative. And I'm going to factor out that GCF. I'm going to write it right in line with what I have here. So I'm going to put a minus 4 for the negative 4. And when I factor out a negative 4, I have minus 4n divided by negative 4. That's a positive 1n, or just n. And then a minus 20 divided by negative 4 is a positive 5, so plus 5. So we're not done, but what do you notice with the parentheses? They're the same. In order for factoring by grouping to work, the parentheses have to be the same. If they're not, either you didn't take out the greatest common factor, or perhaps factoring by grouping doesn't work, in which case it would just mean that you can't factor the polynomial in general. So with this, to finish factoring this, you now have 2 terms. The 3p times n plus 5, that is all 1 term. And then the 4 times n plus 5 is a second term. And these 2 terms have a GCF of n plus 5. They both have an n plus 5 in common. So you now factor the n plus 5 out and write in parentheses after that what's left when you take it out. So if I take an n plus 5 away from both of these terms, I'm left with the 3p minus 4. So this would be your fully factored form. Questions on that one? And when you have two parentheses like this, if I had these two parentheses flipped, that's okay. So if I had 3p minus 4 first and then n plus 5, the order you have the parentheses doesn't matter. You just have to make sure within your parentheses that they're both correct. So go ahead and factor what we have in number 5. And we'll check that we can all factor it. Yes, you could check these ones by foiling. If you used FOIL, you could use that to check if you factored these ones correctly. All right, double check what you have. So if you left the terms arranged the way they are, first two terms have an n in common, second two terms only have a 1 in common, but you do want to take out the negative. So sometimes your GCF, when you factor by grouping, is just 1, positive or negative 1. So r plus 5 times n minus 1, or if you had those flipped, n minus 1 times r plus 5, that's okay. Questions on number 5? Okay, then the last 3 on this front side, 6, 7, and 8. So again, you're checking for a GCF first, always. But now how many terms do all 3 of these problems have? 2. So when you have only 2 terms, the only ways you can factor it is 1, if they have a GCF, and then 2, the only other thing you look for is if it's a difference of squares. Squares meaning perfect squares. So numbers that you can take the square root of, or terms you can take the square root of. So there is a formula for factoring a difference of squares. So if your polynomial is given to you in the form a squared minus b squared, so 2 perfect squares subtracted, it will always factor into this form, a plus b times a minus b. So a is going to be the square root of a squared, the square root of your first term. B is the square root of b squared. And then notice both terms in each factor are the same. One's plus, one's minus. So if we look at 6, we have 16h squared minus 9a squared. First of all, is there a GCF other than 1 for 16h squared and 9a squared? No, they have 1 in common, but that would be it. So then you have to determine, are both of these terms perfect squares? Can you take the square root? So whenever you have a variable is a perfect square if the exponent is even. So if you have a variable squared or a variable to the 4th power or the 6th power, those are perfect squares. So h squared and a squared are both perfect squares. Is 16 a perfect square? Is 9? Yes, you can take the square root. So how I'm going to write this, first of all, what is the square root of 16h squared? It'd be 4, and then the square root of h squared would be h, because h times h would be h squared. And then the square root of 9a squared would be 3a. So this 4h is like your a in this formula. The 3a is like your b. So the factored form is 4h plus 3a times 4h minus 3a. And again, notice I went from a difference of 2 terms to now a product of 2 quantities. I have 4h plus 3a times 4h minus 3. So I have a product. Okay, so if we look at 7, does 7 have a GCF? They have a 3 in common. Anything else? They have a G in common as well. So if you have a GCF that needs to be factored out first, so I'm going to have 3G times, if I divide both of these by 3G, 27G cubed divided by 3G would be 9G squared. And then minus 3G divided by 3G is just 1. And now I still should check, once you factor out a GCF, you still check if what's in the parentheses can be factored further. So I still have 2 terms. I should check if they're both perfect squares. Is 9g squared a perfect square? Yes, square root is what? 3g. Is 1 a perfect square? Can you take the square root of 1? You can. What's the square root? 1. Okay, 1 times 1, or 1 squared, is 1. So I do have a difference of squares. So this, I'm ignoring the GCF right now. This will factor to be 3g plus 1 times 3g minus 1. And then I still have the GCF of 3g in front. So this is the fully factored form of that polynomial, or that quadratic. Okay, so go ahead and factor number 8, 121 minus 4b squared, and then we'll check it before we move on to the back. All right, double check. 11 plus 2b and 11 minus 2b would be the factored form. All right, any questions? All right, on the back, bless you. This we're gonna go through. I know we have to get to the homework quiz. I would say the most difficult part about solving these equations is the factoring. So that's why we just reviewed the factoring. So ultimately, why we factor is to help solve quadratic equations. So this uses what's called the zero product property. And what that states is if you have any real numbers, or this could be any quantities, A and B, if you know A times B is equal to 0, then you know either A has to equal 0, B has to equal 0, or both have to equal 0. The only way to get a product of 0 is if one of the 2 or 3 or 4 quantities being multiplied is 0. So this shows in this example, I need it quiet please. This shows in this example if you have x plus 3 times x minus 5 equals 0, then either x plus 3 would equal 0 or x minus 5 would equal 0. So you're taking each factor and setting it equal to 0, solving those equations to figure out what x could be. So keep in mind you're finding the same solutions we found yesterday on the graph. This is an algebraic way to find those answers. So if we look at 9, 10, and 11, there's really 3 steps you want to follow when you solve by factoring. Your first step, if it isn't already done for you, is to get one side equal to 0. After you do that, or if it's already done for you, then you want to factor the other side. And after you do that, or if it's already done, then you are going to solve using the zero product property. So one side has to be 0, you factor the other side, and then you solve using the zero product property. So if we look at number 9, one side is already equal to 0. Would you say that the left side is factored? No, it is a sum of 2 terms. It's not a product of 2 quantities. So what method would you use to factor this that we just reviewed? There's a GCF. What is the GCF? 5x. So if I factor out a 5x, I have 20x squared divided by 5x. That's 4x plus 15x divided by 5x is 3. And then I still have the equal 0. So now once it's factored, you take each factor and set it equal to 0. So this means either 5x equals 0 or 4x plus 3 equals 0. And then this is where you find your 2 solutions. You solve each of those equations for x. So here in the first one, I would be dividing both sides by 5. And 0 divided by 5 is just 0. So one of my solutions is x equals 0. For the other equation, I would have to subtract 3 from both sides first. So that would be 4x equals negative 3. And then I would have to divide each side by 4. So x would equal negative 3/4, or if you had negative 0.75, that's okay. But these would be your 2 solutions. Okay, are there questions on that? So 10 and 11, I'm not going to go through the whole process, but I want you to understand how it's set up. For 10, one side is 0. Would you say the left side is factored? I heard some yeses. I have a product of 2 quantities. So I can go straight to step 3, solve using the zero product property. This would be either 2d plus 6 equals 0 or 3d minus 15 equals 0. And then you would solve each of those equations for d. Okay, so I'm going to skip over that part. I know you can solve those equations for d, but I wanted you to know how to set up the new part with the zero product property. For 11, so you would have 2 solutions for d there. For 11, you do not have 0 on one side yet. Always, or rather, I would recommend you keep the term that has the variable squared, try to keep that positive. So to get one side to be 0, I would subtract the 36 from both sides. So y squared minus 36 equals 0. And now you have to factor the left side. How would you factor this side? Difference of squares. So this square root is y, this square root is 6. So you have y plus 6 times y minus 6 equals 0. And then you can use your zero product property to solve. So y plus 6 would equal 0, or y minus 6 would equal 0. And solve both of those for y to get your 2 solutions. Okay, so factoring, I just want to make this point. Factoring is not easy. You are not going to understand it more or get better at it if you do not practice it. Okay, probably the last time you really spent a lot of time factoring was 2 years ago. And we use factoring the rest of this year. You need to understand it. Practice. I'm not checking the assignment, but you have to do what you need to do to really learn it. I'll have the evens on the board tomorrow. Odds are in the back.